Today we are going to talk about collision. And before we get into collision, we should know about momentum. Momentum is equal to mass times velocity, and the law of conservation of momentum is the vector sum of all momenta in a closed system is conserved, which means the momentum will remain constant. And now let's look at collision. A collision is an interaction between objects that involves a change in their velocities and therefore in their momenta. And in a closed system of collision, momentum is always conserved, which means that momentum before the collision should equal to momentum after the collision. However, the kinetic energy will not always be the same, so according to the kinetic energy, the collision will be categorized. Under collision, there are three different types of collision. The first is elastic collision, the second is inelastic collision, and the third one is explosive. For the elastic collision, it means that the kinetic energy in an elastic collision will always be conserved, and in inelastic collision, the kinetic energy is not conserved and sometimes transferred to thermal energy. And for explosive, it means that kinetic energy will increase during the process. But however, today we are only going to talk about elastic collision and inelastic collision. As it shows in this diagram, there are two balls and they are running on the same track and there's no friction on it. The first ball have a mass 1 and the second have mass 2, and they have different velocity, which is u1 and u2. And then they collide with each other and create force exchange. And then they change to different velocity, which is v1 and v2. And from this collision, we can get the equation that m1u1 plus m2u2 equal to m1v1 plus m2v2. This is because the conservation of momentum. And as we mentioned before, in an elastic collision, the kinetic energy will always be the same. So, which means that we can use the Newton's second law and third law. F equal to m mass times acceleration, which the acceleration can be transferred to v minus u divided by delta t. And from this equation, we can get that the final momentum minus the initial momentum divided by delta t is same with ma. And then if we get this equation to the equation we get from the collision, we can have m1 times v1 minus u1 divided by delta t equals to m2 multiplied v2 minus u2 divided by delta t. And finally, after a process, we can get that the final momentum is equal to the initial momentum. So therefore, we can see that if there's an elastic collision, the kinetic energy before and after will also be the same. In an inelastic collision, the two balls will have the mass 1 and mass 2, the initial velocity of u1 and u2. And then after they collide together, it will be this. The two balls will stick to each other and then move to the same direction with the same velocity, which means that m1 u1 plus m2 u2 equal to m1 plus m2 times v. From the inelastic equation, we can see that v equals to m1 u1 plus m2 u2 divided by m1 plus m2. Now here's a question. In an inelastic collision, what is the velocity after the collision? And one mass is 3 kg and another ball's mass is also 3 kg, and it has velocity of 3 meter per second and 2 meter per second. And we can solve this using the equation mentioned above, which is m1 u1 plus m2 u2 equal to m1 plus m2 times v. And if we put all the numbers into the equation, we can get the answer of v equals to 15 divided by 6, which is 2.5 meter per second. And in real life, actually, most of the collision are inelastic collision because it is really hard for the collision to conserve all the kinetic energy. This is because there will always be some other factor which will impact the collision. This is because there will always be some factor that impacts the collision. For example, if there's a car crash on the highway, the two cars will slower their speed or even stop after their collision. This is because first, the two driver will step on their brake to stop their car, and the second is because they will lose some heat when they crash together, and that is the reason why sometimes there's fire during a car crash. And the third reason is because the car will have a friction with the road, so the car will slow down after the collision. And the fourth is because the inelastic collision, and the two cars will stick to each other and do not move because they lost their kinetic energy. Therefore, while comparing inelastic collision and elastic collision, it is very obvious that these two collisions all conserve their momentum during the process. However, for the inelastic collision, the two objects will lose kinetic energy through the process, but for elastic collision, the kinetic energy will also conserved during the collision process.